Okay, good afternoon, all. In last lecture, we have discussed about the different types of the alloy steels, and in that we have studied their composition properties along with their applications. Now, in this lecture, we are going to deal with, or we are going to discuss the cast irons. Then, what is the composition of the cast iron? What are the general properties or characteristics of the cast iron? And after that, we are going to discuss how the classification of this cast iron is done on different basis, and we are going to discuss each type in detail after that. So first we will start with the what is the meaning of the cast iron. Now, generally or basically, cast irons are alloys of the iron and carbon, as we have earlier discussed earlier that steels are also alloys of iron and carbon only. But here, what will be the difference here? The difference will be in the composition related to the carbon. In the steels, the carbon percentage is will be within the range of 0.008 to maximum 2%. And in case of the cast iron, the percentage of the carbon will vary within the range 2% to maximum 6.67%. Now, whichever value I have mentioned here, that is carbon percentage from 2% to 6.67%. This is just the theoretical value. In actual practice, it is means the cast iron which has carbon percentage more than 5.3 or more than 5%, it is not possible. That's why in commercially, if you take the commercial, all commercial cast irons means the cast irons which we are using in our practical life, that cast irons generally contain the carbon percentage within this range, that is 2.3% to 3.7%, 75%. This value, whichever value I have indicated here, that is 2 to 6.67%. This is just a theoretical value. In actual practice, we are not using these values. Okay, in actual practice, we are taking the percentage of the carbon within this range 2.3 to 3.75%. Okay, as far as theoretical values of carbon are concerned, it will be within the range 2 to 6.67. And as far as your practical values of carbon percentage in the cast irons are concerned, percentage of the carbon will be 2.3 to 3.75% only. Now, in addition to this, as this is the alloy of the iron and carbon, in addition to this, some alloying elements will be there, like silicon. Now here, percentage of the silicon will be, or composition or amount of that silicon will be within this range only, that is 0.5 to 3%. Then amount of the phosphorus will be zero point 0.1 to 0.3%. Amount of the sulfur will be 0.06 to 0.12%. Manganese will be zero point 0.5 to 1%. Generally, amount of manganese will be decided by considering the amount of sulfur only. Generally, manganese amount will be 5 to 8 times that of the sulfur. These are the basic alloying elements, these silicon, phosphorus, sulfur, manganese. In addition to these, some other alloying elements may be there depending on the desired properties. If you want to improve certain, suppose if you want to improve the hardness of that cast iron, then you can add chromium and molybdenum, like that. If you want to improve other properties depending on that nature, you are going to add the nickel, copper, aluminum, boron. These kind of alloying elements may be there depending on the properties required. Okay, so this is the general or basic composition of the cast iron. In short, you can say that cast irons are alloys of the iron and carbon, where percentage of the carbon varies from 2% to 6.67%. This is theoretical percentage. And as far as commercial or practical cast irons are concerned, the percentage of the carbon will be 2.3 to 3.75%. Okay. Now, in some cast irons, there may be other alloying elements may be there, like silicon, phosphorus, sulfur, manganese, or you can also add chromium, nickel, molybdenum, magnesium, depending on the desired properties or required properties. So this is the composition of the cast iron. This is the general composition. In some specific cast iron type, there may be some variation in the amount of these elements. Okay, because we are varying this depending on our need or our use. Now, after studying the composition of the cast iron, depending on this percentage or amount of the alloying element or basic elements, we are going to decide the properties of the cast iron. Now, before actually going to the before starting actual properties, first we will try to understand why this name is given as the cast iron only. Okay, why these alloys are termed as the cast irons. There is certain reason, because these cast irons are generally, as amount of the carbon or percentage of the carbon is very high here, these materials will be having very poor ductility and malleability. Okay, please try to understand this. Because of the higher percentage of the carbon, these cast irons will be very having very poor ductility and malleability. Due to very poor ductility and malleability, we cannot form or we cannot give the desired shape and size to a certain product by using the forging process, rolling process, or drawing process, or different pressing process also. It is not possible to give the desired shape and size to that material by using our regular processes like forging, rolling. Only we can use the casting process here for these type of materials or these alloys. Only we can give the desired shape and size by melting them and doing the casting process. And at the end, if any machining is required, you can do the machining, or sometimes without machining we are getting our final product. Okay, the only casting process we can use for giving the desired shape and size to these kind of materials. That's why these materials are named as cast irons. Okay, from where this cast iron name came, uh, for that you should understand these properties. Because due to higher percentage of the carbon, these materials are having very poor ductility and malleability. Due to very poor ductility and malleability, to form the desired shape and size product, it is not possible to done this by regular processes like forging, rolling, drawing, or pressing. Only we can use the casting process by initially melting them, and by following the casting process with or without machining, we can give or we can form the desired product with desired shape and size. That's why the name is given as the cast iron. Okay, and in properties you can write also that they are having very poor ductility and poor malleability. That will be your first property. And why these are termed as cast iron, for that you have to give this explanation, their property. And due to this property, you cannot give the desired shape and size with forging, rolling, and other processes. Desired shape and size can be obtained only by melting them and doing the casting process. Okay, then after this, related to the cost, as if you compare with these alloys with the steels, they are having very lesser cost. Means you can write like this: they are the cheapest among the commercial alloys. Whichever commercial alloys are available, these are having the lesser cost. Okay, these are having the lesser cost. This is another property. Then the next property will be, they are very easy to melt. Okay, they are very easy to melt. Why they are very easy to melt? Because their melting point is very less. If you compare these cast iron material to the steel materials, almost all steels and alloy steels, whichever alloy steels are there, they will be having very higher melting point, more than 1350 degrees Celsius. In this bracket I have mentioned the melting point of steels. Generally steels are having very high melting point, and whichever cast irons are there, their melting point is somewhat smaller or lesser as compared to steels. That's why the melting process becomes very easy. Then next property will be, they have excellent castability. Now, they are having excellent castability. Then how this castability is determined? because you can do the melting of these materials very easily, and they are having very high fluidity. Whichever melt is formed, they will be having very high fluidity, and at the end, whichever component is formed, whichever end product is formed during this casting process, the shrinkage will be very less after the solidification process. This is another property of the cast iron material. Then these cast iron materials provides fairly good corrosion. Not means this corrosion property will be not comparable to the steel, but they will provide somewhat better resistance to the corrosion. But steel will be best for this. But as compared to steel, they will be having lesser corrosion resistance. But you can use this cast iron in the for different practical purposes also. Okay, means in short, you can write like this: their corrosion resistance is fairly good. It will be lesser than the steel, but it can sustain during the your practical applications. Now after this, the next property is the next property. You can alter the properties of the cast iron depending on your requirement. Okay, you can change the properties of the cast iron as per your need. You can improve their hardness, or you can somewhat improve their ductility and machinability by doing different alloying methods. Proper, here I have mentioned the word, by doing the proper alloying. Proper alloying is nothing but addition of the different alloying elements. Okay, whichever change you want, depending on that change, you can add the different elements. That process is nothing but your alloying process. Or you can change their properties by doing the good foundry control. There is foundry control means you have to control the whichever casting method you are using for manufacturing the products. You have to control the parameters to change the properties here. And you can use the suitable heat treatment processes. Different heat treatment processes are there. Depending on whichever change you want in that material, different heat treatment processes you can apply here. In short, just you have to remember this, that is, depending on our need, you can vary the properties of the cast iron by changing their composition, or by performing different heat treatment processes. Then next properties, in general, these materials are brittle in nature uh, as compared to these steels. Okay, these are brittle in nature, and their mechanical properties will be inferior to the steels. Okay, inferior to the steels means whichever strength or whichever tensile strength is there, that will be lesser as compared to the steel material. That, and these are the different properties of the cast iron. Now, for example, I have taken here some types of the cast irons I have mentioned here. That is, cast irons, depending on their properties, different types of cast irons are there. Means, suppose if you want to use or the manufacture a component having high hardness and high wear resistance or high corrosion resistance, then you can use white cast iron. And suppose you want to manufacture a component which requires excellent machinability and very good damping capacity, then you can go for the gray cast iron. And suppose if you want to manufacture a component which is having very good toughness and very good impact resistance, then you can go for the malleable or nodular cast iron. These all types we are going to study in detail or in brief, but just try to understand that depending on the required properties or required application, we can change the properties of the cast irons, and we can use that cast iron depending on our need. You can change the properties, and you can change their characteristics, and you can apply to your practical use. Okay, so these are the different properties. uh, okay, just we have studied whatever. I will repeat it. Means, in short, I will tell you, we have seen the composition of the cast iron, then their different characteristics or properties. You can say that after seeing these properties or studying these properties, we will go move towards the next point, that is the classification of the cast irons. I will wait for 1 minute or 2 minutes here. Just you have to draw this chart of classification of the cast iron. I will wait for 2 minutes here. After completing, mention that in the chat box that you have completed this chart. Please draw this classification of the cast iron. Okay, whichever classification part is there for this cast iron, these first two bases I have given for your information only. In your syllabus you are having only this last part, that is classification on the basis of the microstructure and appearance of the fracture. Okay, these first two types are not in your syllabus. Just I have given you for your information purpose only. This last type, that is on the basis of microstructure and appearance of the fracture, and this will be this part is in your syllabus in detail. Means all these types we are going to study in brief. Whichever seven types are there for this cast irons, each and every type we are going to discuss in brief along with their composition properties, then their different types, and for each type they are having some specific application or specific characteristics that we are going to deal with. Okay, now I will explain it in short. First two types, that is the first classification. The first classification, whichever names you are seeing here, four types. This classification is done on the basis uh, whichever furnace you have used for doing the manufacturing. Okay, whichever furnace is used for manufacturing of that cast iron, depending on the type of the furnace, they have given the name like cupola cast iron, then air furnace cast iron, electric furnace cast iron, and duplex cast iron. Okay, here cupola furnace is used for manufacturing of that cast iron. Then the name is given as cupola cast iron. This cupola is the name of the furnace. Cupola furnace is there. Then air furnace is there. If air furnace is used for manufacturing of that cast iron, it will be termed as air furnace cast irons. If suppose you have used the electric furnace, then it will be termed as electric furnace cast iron. And what is the meaning of this duplex cast iron? Here, uh, any one two furnaces from the above list, whichever three furnaces I have mentioned here, either cupola furnace, air furnace, and electric furnace. In the one furnace, in the duplex furnace, you are using two different furnaces. For doing the melting operation, you are using one furnace, and for doing the remaining refining process or alloying process, or if suppose any other heat treatment is required for performing that, if you have used another type of furnace, suppose initially you have used the cupola furnace for doing the melting of that cast iron process, cast iron material, then that will be your use of first furnace. And if suppose you have done the remaining heat treatment or refining process in the electric furnace, okay, means you have used here two furnaces. That's why the name is given as duplex cast iron. In the duplex cast iron, you have to use any two types of the furnaces. One is used for the melting melting process, and another will be used for refining, alloying, or you can say that doing the heat treatment process as per our need. That's why it is named as the duplex cast iron. Means you have used the two furnaces depending on the operations. Okay, in this way, depending on the basis of furnace used in the manufacturing, the cast irons are classified in these four types: cupola cast iron, air furnace cast iron, then electric furnace cast iron, and duplex cast irons. Then after this, the classification of the cast irons can also be done on the basis of the composition and the purity. And here only three types are there depending on the composition and the purity. Simply this classification is done on the basis of the composition only. The first type is low carbon, low silicon. The percentage of the carbon and silicon will be low. The second type will be high carbon and low sulfur, high carbon and low sulfur cast iron. And third is the nickel alloy cast irons. Okay, here nickel will be present in the somewhat, you can say that as a dominant alloying element will be nickel here. That's why the name is given as nickel alloy cast irons. Okay, so these are the first two classification. One is based on the classification on the basis of furnace used for manufacturing, and second classification is done on the basis of their composition, you can say in the short way. And the third, now this will be asked in your examination, uh, classification of the cast irons on the basis of their microstructure and their appearance of the fracture. Appearance of the fracture, or you can say that whichever appearance or color you are able to see under the microstructure when you are observing their microstructures or studying their microstructures. On that basis this classification is done. Here I will explain in short way all these seven types. We are going to study in one by one in brief. I will explain it in short. Now, white cast iron. Okay, first is the white cast iron. Now, which microstructure or which phase is there? Generally, in the white cast iron, cementite phase will be there. Okay, if you observe the microstructure of that cast iron, you will be able to see the cementite. Means here carbon will present in combined form. Okay, free carbon is not available. Whichever carbon is there, it will be present in the form of cementite. Cementite is nothing but Fe3C. Okay, this is the chemical formula for that cementite. Means carbon will present in the combined form, and whenever you are observing it under the microscope, its appearance will be, or whichever fracture is there, that appearance of that fracture will be white colored. Okay, white color, and that white color is due to the cementite. Okay, in short, in white cast irons, carbon is present in the combined form. Free carbon is not available. Carbon will be present in the combined form as a cementite. Its chemical formula is Fe3C. Okay, that will be your white cast iron. Then next is the gray cast iron. Now, in the gray cast iron, here free carbon will be available. In white cast iron, free carbon is not available. Free carbon means only carbon, not in the combined form. Here carbon will be available, free carbon will be available in the form of the graphite. Okay, whenever you observe the their microstructure under the microscope, you will able to find flakes like structure. Means dark flakes will be there. Okay, I will show you the microstructure diagrams in the next lecture. I have not taken that photos. I will collect that and I will show you the microstructure for each type in the next lecture. Just try to understand this. That is, in the white cast iron, carbon will present in the combined form and it will be present as a cementite phase. Now, in the gray cast iron, here free carbon will be present, and that carbon will present in the form of graphite. If you observe their microstructures, you will be able to see black flake like structure will be there. Black colored flakes like structure will be there. Okay, some thick lining structures it will be visible under the microscope. That will be your gray cast iron. Then the next type is malleable cast iron. Okay, malleable cast iron is there. Now in the malleable cast iron, here in the malleable cast iron, whichever graphite, again as we have discussed in the gray cast iron, carbon will be there. In the malleable cast iron also carbon, free carbon will be there. In the nodular cast iron also there will be free carbon. Okay, in gray cast iron, malleable cast iron and nodular cast iron, free carbon is present, but their shape will be different. Okay, in gray cast iron, whichever free carbon is there, it will be present in the form of thick flakes. Flex means, in short, suppose, for example, if you have seen that bingo chips are there, bingo, you can see that that advertisement is there, bingo tede mede, like something, that advertisement is there. If you have eat that bingo flakes are there, okay, like that kind of microstructure you will be able to see, means thick flakes. Okay, are you able to understand this? Yuvraj Sailor, please reply me. Okay. Anyone? Roll number nine. Are you there? This roll number nine. Rutuja Tarapurkar. Please reply me. Roll number eight. Then roll number 55. Rajwal is there.
Yes, sir.
Are you getting my the whichever concept I am telling you related to that
Yes, sir.
stuff? Okay, okay. Why other persons are not giving reply? I will take another person's. Okay, I will repeat it. Now, in the white cast iron, carbon will present in the combined form and its color will be white. In the combined form means it will appear as a Fe3C, that is the in the form of cementite. Now in gray cast iron, then malleable cast iron and nodular cast iron, in all these three types, you will be able to identify the free carbon. Free carbon will be there, but their appearance or their what you can say that their morphology will be different. Appearance or morphology will be different. In gray cast iron, that carbon will be free, but it will appear in the form of flakes. In the malleable cast iron, it will appear about spherical form, not exactly spherical, but irregular sphere form, irregular shaped sphere in the malleable cast iron. And in the nodular cast iron, it will appear spherical in nature, complete spherical. Okay, in malleable cast iron, irregular spherical form will be there, and in nodular, complete spherical form or complete spherical appearance will be there. In all these three types, carbon will be free, but their appearance will be different. Okay, and next is the mottled cast iron. And in the mottled cast iron is combination of white cast iron and gray cast iron, means some free carbon will be there in the form of flakes of the graphite, and some carbon will be in the form of combined form, that is the cementite. Okay, carbon will be present in the two forms, as cementite also and as a graphite also, and their distribution will be random. Okay, means they may present at the surface or they may present at the core of the product. Now in the next type, in the chilled cast iron, here Here also you will get the combination of the white cast iron and gray cast iron, but their spot is fixed. Means on the surface, whichever product is there, on the surface of that product, you will able to find the white cast iron. Means cementite will be there, and at the center of that product, at the center of that product, there will be gray cast iron. Okay, there will be gray cast iron, and that type will be termed as the chilled cast iron. Okay, in this way mottled cast iron and chilled cast iron is there. Mottled and chilled both contains combination of white cast iron and gray cast iron, but in the mottled cast iron, distribution of that white cast iron means cementite and gray cast iron means graphite flakes. Distribution of that white cast iron and gray cast iron is random. In the chilled cast iron, white cast iron will be present on the surface, and gray cast iron will be present at the center of that product or core of that product. Then the next type or last type, depending on the microstructure and their appearance, is alloy cast iron. Now, if suppose you have done any changes in the properties or any changes in the composition of above six types, in above six types, if you have made any changes related to their composition, and whichever new cast iron is formed, that new cast iron will be considered as a alloy cast iron. Okay, that separate kind will be termed, or it will taken in the category of the alloy cast iron. If in above six types, whichever six names I have mentioned, white cast iron, gray cast iron, malleable cast iron, nodular cast iron, mottled cast iron, chilled cast iron, if you suppose you have made any changes in the composition or their properties, whichever new cast iron is formed, that will be considered in the category of alloy cast iron. Okay, so this is the classification of the cast iron, depending on the basis of their furnace used in the manufacturing, then depending on the basis of their composition, and the last and main classification is depending on the basis of their microstructure and appearance. Then after studying this brief classification, the next is the factors influencing their microstructure. Okay, whichever how or which elements are affecting the microstructure of the cast irons. The main classification which we have discussed is on the basis of their microstructure only. Microstructure or whichever phases are present in that cast iron. Now, which factors will affect the microstructure? If you are able to understand these factors, you will be able to understand, or if you will be able to change their properties depending on your need. Okay, now the main six parameters or six elements are there which will change the microstructure. Whichever microstructure is there, if you change these parameters, that microstructure will get affected. As microstructure will get affected, only depending on that microstructure, the type is decided, then automatically that type will get changed. Okay, now we will discuss one by one what is the effect. I will explain it in very short manner. Then what is the effect of, suppose here I have taken almost the five factors are amount of the certain elements. Okay, first factor is amount of carbon, second is amount of silicon, and third is amount of phosphorus, then amount of sulfur, fifth is amount of manganese, then sixth is the cooling rate used. Now before I will explain it, the first three, okay, first three elements, that is amount of carbon, amount of silicon, and amount of phosphorus, these are having same effect. Okay, amount of carbon, silicon, and phosphorus, these are having same effect. Means this carbon, silicon, and phosphorus, these are strong graphitizers. Okay, graphitizers, and they promotes the graphitization process. Now here question arises, what is the meaning of graphitization? What is the meaning of graphitization? Graphitization is nothing but separation of the carbon, separation of the carbon process, and that separated carbon, free carbon, will be termed as graphite. Are you getting this? Separation of the element carbon or formation of free carbon, that will be termed as the graphitization process. And these initial three elements, carbon, silicon, and phosphorus, these are strong graphitizers and they will promote the graphitization process. If you increased the amount of carbon or silicon or phosphorus, it will increase the graphitization process, means it will increase the formation of free carbon in the form of graphite. And as it increases the formation of free carbon in the form of graphite, it results in the formation of the gray cast iron. As gray cast iron is consisting of free carbon in the form of graphite flakes. Depending on the microstructure only, we have decided its type. That is, gray cast iron consists of free carbon in the form of flakes. Okay, and this carbon, silicon, and phosphorus, if you increase their amount, it will act as a graphitizing element or graphitizer, and they will promote the graphitization process. Means separation of the carbon in the form of graphite will increase, means the formation of gray cast iron will increase. Means whenever percentage of carbon, silicon, and phosphorus increases in the cast iron, it results in the formation of the gray cast irons. Okay, so this is the effect of first three elements. Then amount of sulfur and manganese. Now the sulfur and manganese, these will act as the carbide stabilizer. Okay, sulfur and manganese, they will act as the carbide stabilizer. Carbide stabilizer means they will try to combine the carbon. They will try to combine the carbon, and hence they will result in the increase in the phase, that is the cementite phase. As sulfur and manganese amount increases, the amount of cementite also increases, and as amount of cementite increases, form automatically, it will result in the formation of the white cast iron. That is the effect of sulfur and manganese. Carbon, silicon, and phosphorus, they will act as the graphitizer. They will increase the graphitization process, means they will increase the formation of graphite. Means they will try to separate the carbon in the form of graphite, and it will result in the formation of gray cast iron. And then sulfur and manganese, they will act as the carbide stabilizer, or they will act as the influencing element, or the element which promotes the formation of the cementite. As sulfur and manganese amount increases, formation of cementite increases, hence the amount of white cast iron will be more when sulfur and manganese amount increases. Then the last factor is the cooling rate. Now cooling rate, maybe it may be slow cooling rate, or it may be faster cooling rate. Whenever faster cooling rate is there, whenever cooling rate is very fast, whenever cooling rate is very fast, it will suppress the graphitization process. Okay, suppresses the graphitization means no free carbon will be there, means large amount of cementite will be there. Okay, large amount of cementite means, in short, you can say that whenever faster cooling rate is there, more amount of white cast iron is there, and whenever slower cooling rate is there, gray cast iron amount will be more. And why this is happening? Whenever rapid or faster cooling rate is used, graphitization process is not present there, or graphitization does not occur. And due to absence of this graphitization process, free carbon will not be there, and as free carbon is not present, gray cast iron is not formed, only white cast iron will be there. Whenever rapid or faster cooling rate is there, white cast iron is formed, and for slow cooling rates, uh, gray cast iron is formed. Okay, so this is the effect, or these are the factors which will affect the microstructure, and due to that change in the microstructure, different types of the cast irons will be formed. Okay, please, you can note down these points, these factors influencing the microstructure of the cast irons. Please note down this. I will wait for 1 minute. Okay, now after studying these different factors influencing the microstructure of the cast irons, now we will start the study of different types of the cast iron one by one. And that the first type is the white cast iron. Okay, this is the first type of the cast iron, that is the white cast iron. As already I have explained this, in the white cast iron, in the white cast iron, carbon is present in the combined form, and it is present as the cementite. It is present as the cementite phase. Carbon is present in the combined form, as cementite is nothing but Fe3C. Sorry, carbon will be present in the combined form as element or as a compound cementite. No free carbon is there, that is no graphite will be present in this white cast iron. And whenever you study the fractured surface under the microscope, you can easily observe that only white colored surface will be there, and that white color is due to presence of the cementite. Okay, and due to that white color appearance, this name is given, or this type of cast irons are termed as white cast irons. Okay, if you observe their fractured surface under the microscope, that cementite, due to presence of this cementite, you will be able to see white colored layers, and due to that appearance only, this kind of cast irons will be named as white cast irons. Okay, white cast iron, from this appearance color, the name is given as white cast iron. Now these white cast irons follows the same equilibrium diagram, follows same equilibrium diagram, which equilibrium diagram we have studied for the steel. Okay, depending on that equilibrium diagram, these white cast irons can be classified in three different types. Okay, uh, these three different types are hypoeutectic cast irons, then eutectic cast irons, and hypereutectic cast irons. Okay, they will exactly follow the same equilibrium diagram. Okay, I will show you that equilibrium diagram, which diagram we have studied for the steel. Okay, depending on that equilibrium diagram only, these are classified in three different types. Okay, okay, this is the equilibrium diagram for the steel, or you can say that iron carbide equilibrium diagram. Now, okay, I will explain it how this classification is done. Please wait for 1 minute, whether it is possible to zoom it. Okay, now I have zoomed it. Mm, I think you will be able to see this. Now, this point, okay, this point here, the percentage of carbon is 4.3. Please concentrate here. This is iron carbide equilibrium diagram, and this point is 4.3% carbon percentage. Okay, 4.3% carbon. Now, this alloy will be termed as eutectic cast iron. Okay, whenever composition is less than 2%, whenever in that alloy iron and carbon alloy is there and carbon percentage is less than 2%, it will be termed as the steel only. And whenever carbon percentage is more than 2%, more than 2% means towards this right hand side, all these alloys will be considered as, whichever alloy of iron and carbon is there, these will be termed as the cast irons. Now these cast irons, whenever carbon percentage is exactly 4.3 at this point, okay, at this particular point 4.3% carbon will be there. At this point, that cast iron will be termed as the eutectic cast iron, because here eutectic transformation is occurring. This liquid will get transformed to mixture of two solids. Liquid will get transformed to mixture of two solids, austenite and cementite. This mixture is termed as the lead burite. Okay, just try to understand this. When carbon percentage is exactly 4.3, then that type of the cast iron is termed as eutectic cast iron. And when carbon percentage is less than 4.3 but more than 2%, within this range, whichever cast iron will be there, that will be termed as the hypoeutectic cast iron. Hypoeutectic cast iron, carbon more than 2 and less than 4.3%, it will be termed as hypoeutectic cast iron. And when carbon percentage is exactly at 4.3%, it will be termed as eutectic cast iron. And when carbon percentage is more than this 4.3%, it will be termed as hypereutectic cast iron. Okay, more than 4.3%, it will be termed as hypereutectic cast iron. Okay, this is related to the types of the white cast irons, and generally these are all white cast irons because of presence of this cementite. This Fe3C is nothing but cementite. This Fe3C is nothing but the cementite phase. Okay, so these white cast irons are classified in three types depending on the percentage of the carbon. When carbon percentage is exactly at 4.3, it will be termed as eutectic cast iron or eutectic white cast iron. When carbon percentage is within the range 2 to 4.3, within this range, it will be termed as hypoeutectic cast iron. And when carbon percentage is more than this 4.3, it will be considered as hypereutectic cast iron. And in case of steels, already I have explained this, the carbon percentage will be less than 2%. Whenever exactly 0.8% carbon is there, that is eutectoid steel. When it is less than zero point 0.8 and up from 0.008 to zero point 0.8, it will be hypoeutectoid steel. And whenever carbon percentage is more than zero point 0.8 and less than this 2%, within this range it will be hypereutectoid steel. And exactly at zero point 0.8, it will be eutectoid steel. Okay, so this is the classification. Now we will continue towards actual type. So depending on the percentage of the carbon, this white cast iron can be considered as hypoeutectic, eutectic, and hypereutectic. Whenever hypoeutectic cast iron is there, then it is having carbon percentage 2% to 4.3. Whenever exactly 4.3% carbon is there, it will be termed as eutectic cast iron. And whenever carbon percentage is within this range, more than 4.3 and less than 6.67%, then it will be termed as hypereutectic cast iron. Okay, and I will move towards the next slide. Now this is the white cast iron, and I have written there general composition for the white cast irons. Okay, this in general, this white cast iron will be consisting of these elements: carbon, and carbon percentage will be 2.3 to 3%. These are commercial white cast irons. Okay, don't get confused between theoretical values and commercial values. Theoretical values we are not using in the actual practice. These are the actual practical values or commercial cast iron values. Carbon percentage will be 2.3 to 3%. Silicon will be 0.5 to 1.3. Sulfur will be 0.06 to 0.1. Then phosphorus 0.1 to 0.2%. Manganese will be 0.5 to 1%. Okay, so the, and remaining will be iron. Remaining will be iron. Iron will be here basic element. Same as that of the steel. Steel also consists of the base element will be iron only. Here also basic element will be, or parent element will be iron only. Then their properties. These white cast iron, as the main phase present, as main phase present is the cementite. These are having higher hardness. These are stronger in nature, and their wear resistance and abrasion resistance is very high. And as they are having high hardness and stronger in nature, they these cast irons or white cast irons are difficult to machine, and whichever higher hardness or higher wear resistance or abrasion resistance is there, this property is due to presence of the cementite. As carbon is present in the form of cementite, due to that only hardness will be high, wear resistance and abrasion resistance will also high. Now some of their applications, these cast iron white cast iron materials are used for manufacturing of the wearing plates, road roller surfaces, then pump liners, mill liners, grinding balls, then extrusion, sorry, dyes for dyes and different extrusion dyes, and whichever different nozzles are manufactured there. For that, you can use the white cast iron. Some pictures I have taken here. These are the wearing plates. Okay, whenever large amount of wear is occurring, we are covering that. Suppose one expensive material is there, and during the practical use large amount of, due to the friction, large amount of material loss is occurring, then that material will be covered with the thin layer of this white cast iron. One layer is given, that will be termed as the wearing plate. Then this road roller, okay, this surface is there, this surface, are you able to see this surface? Whichever road roller we are using while constructing the roads, this road roller surface is made up of the white cast iron only. This is made up of white cast iron road roller surface. Then the next application, different grinding balls. Okay, you can use different steels also for this, but largely we are using for manufacturing of these grinding balls, we are using the white cast iron material only. Then different pump liners are there. You can use the, these are the pump liners. Here you can use different cast irons. Then these are the extrusion dyes and nozzles are there. But here I have taken the diagram from the steel. Don't get confused here. I have taken the diagram of steel, but in large amount they are using the, you can say that the cast iron material for manufacturing of this. In appearance, you will get confused that whether it is a steel. Also, this is the cast iron. The different extrusion dyes and different types of the nozzles we are here using for the manufacturing of these. We are using the white cast iron only. Okay. So before starting the next type, we will stop here only. In this lecture, we have covered the what is the meaning of cast iron, why they is given as the cast iron only. Then after that, we have studied the properties. First we have studied the composition, then we have studied the properties of the cast iron, then on which basis classification is done of the cast iron, then which are the influencing factors, or which are the factors which will affect the microstructures. And after that, we have discussed the first type, that is the white cast iron. And this, in this, we have studied uh, what are the phases present in that white cast iron, then their types, then their properties, their composition, and some specific applications we have studied, like wear plate is there, road roller surface is there, then grinding balls, pump liners. All these we have studied during this lecture. Now in next lecture we will try to discuss about the different types, that is malleable cast iron, then modular cast iron, then chilled cast iron, mottled cast iron, and alloy cast iron, that we will discuss in the next lecture. Okay, I will stop here. Thank you.